Hey math kids, today we're going to talk about displacement and just a quick conceptual note. Displacement is just how much distance we cover. And so if we're going from O to P, displacement is the difference between these 2 points, or the amount of length that we travel. Okay? Now, let's just jump right in. So it says a lighthouse is situated at the top of a cliff. So we have a cliff, we have a lighthouse, and stone falls past the base of the lighthouse and lands after 6 seconds in the water. So somebody throws something here, and 6 seconds pass. Okay. We're given a displacement function. So S of t is equal to negative 5t squared plus 20t plus 25m. And once again, that happens between 0 and 6 seconds. Okay, it says find the initial displacement of the stone. So all we need to do to find the initial displacement, or the height that it is from the water, is plugging in 0. So we're finding S of 0. We plug that in, that's going to go away, that's going to go away. We'll be left with 25. And so that is our initial displacement. Now it says use quadratic theory to graph this function. And so when we're doing that, we want to factor this. So we're going to factor out of 5. So we get negative t squared. Or actually, let's just take out a negative 5. That's going to be easier. So if we take out a negative 5, we're left with t squared. If we take out a negative 5 here, we get negative 4t. Take out a negative 5 here, we get negative 5. Okay, this is still equal to S of t. And then we want to t factor this, so 1 and 5. I'm going to do a negative 5, positive 1. So t plus 1, t minus 5. We still have the negative 5 out in front. Okay, and then from this we can pull out roots if we want to, negative 1 and 5. Okay, so we know initially we start at 25. Okay, and then we have a curve, goes like this, and then let's see, let me draw that a little bit different. Okay, so we have this and this. We know we're going to cross at 5 and negative 1, but the stone, that's part of the parabola, but it's not the stone itself. I almost sneezed, okay. And then it's going to go like this. Okay, so this is 25, and we know that we cross at 5 right there. Okay, now after, if we're assuming that this is like the top of the cliff, then we know this is going to occur at 6 seconds. Okay, so remember the x-axis is seconds. It's measuring the time. Okay, now part C says at what time and place does the stone change direction? So on the graph it changes direction right here, and so it's asking at what time and what place. So it basically just wants the x comma y value of the vertex. And so what we can do is we can use our axis of symmetry equation, which is negative b over 2a. And so if we just look at this, we get negative 20 over 2 times negative 5. So that gives us negative 20 over negative 10. Negative 20 divided by negative 10 is just positive 2. So that tells us that t equals 2 is our x value right there, or our t value. And then to find what the y value would be, we're just going to plug that into the original equation. So I'll write that right here. I'm going to plug in 2 for all of the t's. 2 squared is 4. 4 times negative 5 is negative 20. 20 times 2 is going to give us positive 40. We still have our 25. Add these together, we get 65. And that's going to give us 45. So that tells us that we're 45 meters above ground level. Okay. So the distance from here to here is 45 meters. And that happened at 2 seconds. Okay. And then the last part on this says, for what time interval is the stone above ground? Well, we already know that from the graph, from 0 to 5. Because we know from right here that we have a root that's at 5, and we can see that it's above ground for the rest of the time right there. And so if we write that time interval, we're just going to write it like this. So that's what it's above ground. Okay, if you need additional help, please come to Math Lab. Until then, calculator.